technologies. Of course, our lens is a Leica lens, Dicoma, known from our formerly camcorders. It means that it has passed the Leica inspections. Resolution, contrast is what they're looking for, and so it's the Leica lens is the guarantee for rendering like really sharp and crisp images and have a very subtle shading and basically give you a quality guarantee. The sensor we have talked about, the 1.1 over 2.5 inch type. It has an increased readout speed. It has a different processing on the sensor itself. Some people refer to it as the LSI, the large scale integration. And so it can handle, and that's the decisive part for you, can handle 4K and 60p. We have a suppression of rolling shutter effect. Rolling shutter means not every pixel is read out at the exactly same time. This is a global shutter. Global shutter we haven't implemented yet, actually no one has. And reading out one pixel after each other, of course, means that there's a time difference between pixel 1 and pixel 8 million. And this time difference in certain situations with movement could lead to some optical distortion. That's called the rolling shutter, because you're rolling along the shutter. And this is being suppressed by, of course, calculation, internal calculation. So we have a rolling shutter suppression in here that we also have in Lumix that you know you're familiar with. There's a menu entry in Lumix. Same here. Made possible by, and that's the next point, Venus. So Venus is our processing unit, well known from Lumix, and now finally integrated into our semi-professional camcorder line. It has a very large, very fast LSI large scale integration, so it's a processes on pixel scale very quickly and accurately, and that is what makes the 422 10-bit possible. So formerly we had 420 8-bit in X1000, sorry. So now we can do 422 10-bit, which is quite a decisive factor, as you will learn. Looking at the lens, Leica Dicoma, 24 times zoom, so highest zoom in Palm Semi-Pro camcorders, so we have a decisive factor bit rate. Very large opening, sensor we talked about, 25mm wide angle, high precision AF, even though we're recording 4K. You have seen on the overview we have 2 manual rings and 1 jog dial, so very sophisticated operation possible. Hybrid image stabilization, I will tell you later how this is translated into reality, and internal ND filter, important, not electronical ND filter, so it's not a simulation, there's actual physical ND filters in here. Promised you to have the feature slides. Here you see the comparison of X1000, 30mm wide angle versus 25mm wide angle. So you get an extra amount of view. Optical 24 times zoom, I've explained earlier, so you get all parts of the scene, not only the overview, but also the detail. 2 manual rings, focus and zoom or iris. It has been improved. We have improved operation. If you have an X1000 or X1, compare the operational of the zoom rings. They are finer, they operate nicer. So just a comparison if you want to do it with a customer has been improved. As I said, the zigzag can be influenced by the speed and the pressing that you give to it. By that making it really a smooth operation. ND filter, here you have it on the both use cases on the simulated pictures. Either it's very, very bright outside and you just want to get the light out, or you want to use a slower shutter speed in order to make motion visible. Then you put the ND filters by this simulating less light in, and you can use slower shutter speed to make motion visible. The ND filters, it's 2 of them in here. One of them has blocks down to 1/4 of the light. One of them blocks down to a 1/16 of the light. If you use both of the filters at the same time, you get to 1/64 of the light. It sounds crazy to use only this tiny fraction of light, but especially when you're in very bright environments, like in the desert or on the beach, and you have sunshine and reflection from the water, you need to block more light than you think if you want to make motion visible. That's why this is so important. And here you see the ND filters are being activated. 4K high precision AF. Translation to this, we have the same AF possibilities that you know from Lumix. It's as speedy, it has the tracking performance that we have on the Lumix with the small sensor, so you have to compare 1/2.5-inch sensor to 1/2.5-inch sensor. So the performance will be way better in video than you are comparing to a big full-frame Lumix, because the full-frame Lumix has got totally other challenges. It's way easier to track and to focus on a small sensor. So we have a tiny sensor here, it's even smaller than my nail in here, so it's comparably easier to focus and to track. So all the options we have on the Lumix Compact in 4K, we have here as well. The speed, the tracking, the stability, due to having Venus in here. The face detection also has been improved. Formerly, also we had face detection on camcorder level, but it was a different methodology. Now with Venus we use the same kind of methodology and full-time analysis of the sensor input that we do in Lumix. And also, that's the example here, you can use the data, the color data that the Venus extracts from the data from the sensor to interpret where is the face going. So face detection works a lot more precise than before due to us having this kind of color data by Venus engine. The focus, realize, of course this is a touch screen, like we're used from Lumix. Of course this is a touch screen, so you can touch anywhere, also to define, okay, what should be tracked. You just tap on the screen. Y-get is something we know from Lumix as the luminance marker. So Y-get means if I tap that position, this exact position gives me the luminance data that is this position. So if I want to adjust my exposure to this decisive area, I tap it, and Y-get, or luminance spot meter as we call it in Lumix, gives me exactly the information to adjust my exposure to this part of the image. Focus assist in manual focusing, we can expand like in Lumix, so magnification is possible. We can give a peaking, so we can basically give a color tint to the distance that I have focused. So if I want an indication in red or green or blue, I'll have this peaking that contours the part that is in the distance I'm focusing. I can combine it, the expansion and the peaking, and I have a one-push AF, which means even though I'm working with a manual focus, I can say, okay, do my job now, push in and it will focus on that spot, and then I can take over again. Now we're coming to the image stabilization. It's a hybrid system. It means that it combines an electronic stabilization with a mechanical stabilization. In this case, the sensor is being stabilized electronically in 3 ways: vertically, horizontally, and rolling. That's electronic stabilization on the sensor plane, with an optical stabilization, meaning the mechanical thing happens in the lens. So in the lens, in the front part, we have the other 2 axes, these and this. And when you look at the lens unit, you can see that this is done on 3 points. And one of the improvements that instead of cubic kind of hinges, we have a ball, or 3 balls, that basically are the transition between the moving unit and the surroundings. Why is that relevant? It is relevant because of friction and because of stepless operation. So basically, especially very small movements like hand jitter, something like that, is something that happens on a very small scale. And whenever I have something that has a stepping, the stepping has to match the motion. If I have a ball and I don't have steps, I can adjust these small movements much better. So the ball AS leads to better performance in small frequency movement and much smoother operation. So this is the improvement on the optical side. And the optical side, the 2 axes are being combined with the electronic side, which has 3 axes. And this is why we have a 5-axis hybrid image stabilization. Hybrid, electronic and optical. 5 axes, 3